This is how to pass outcome 2 of Unit 1 now. So as we can see here, we require 6 marks out of 8 or higher. So question 1, the diagram below shows part of the graph y equals f of x. Sketch the graph of y equals negative f of x. So on your paper I would sketch this out, and then to sketch negative f of x we are flipping that in the x-axis. So flipping it up and down the way if you like. So draw it out like this, and then think of flipping it over. So if I have to flip this up and down, it's going to look like that. Make sure you annotate the values in. So this is 2 here. It's going up to positive 3 there. So when you reflect it in the x-axis, it's going to go down to negative 3 and back up. They're going to cut each other at this point here, but we didn't have this value in the original graph, so we didn't need to worry about that. That's it. You would get 1 mark for doing that in the nav. Okay, part B. On a separate diagram, so we have to do a brand new sketch the graph of y equals f of x plus 4. So this is a horizontal shift this time, and we're shifting it back 4 places. So sketch the graph out like this, and then shift it back 4 places. So for shifting this back 4 places, it's passing here at 2, so that would go 2 here and then another 2 to there. So this kind of minimum turning point here would go all the way to negative 2 to shift it 4 places. So that would go back like this. And that's our shift. The only other thing we need to do is we need to mark in where the new turning point here, the maximum turning point. So we can see the maximum turning point happened up at 3 here. So it's happening at negative 4, 3 now. So we'll mark that in. And I'll just mark it in with a point. There. Okay, so that's my new sketch. I've got negative 2 here, and I've marked this point in as negative 4, 3 because it's moved back 4 places. Okay, next question, question 5. The diagram below shows the curve y equals sine x and the related curve. Write down the equation of the related curve. So let's sketch a mark here to do this. So we can see the sine wave here from 0 to 360, and it's gone up to 1 down to negative 1, but it's been shifted down the way. Now let's look at this point here. This is at 0, and the new wave is starting at negative 2, so it's been shifted down 2 places. Same idea, it's peaking at 1, and then in this graph it's peaking at negative 1, so that's been shifted down 2 places. So sine x take away 2, y equals sine x take away 2 for a mark. The diagram below shows the curve y equals cos x and a related curve. Write down the equation of the related curve. So here's y equals cos x, going down to negative 1 and up to positive 1. The new curve, this one here, only goes down to negative half and goes up to positive half. So that's the value at the front there that's changed. It was a 1, it's now a half. So the new function is y equals a half cos x. Put a mark. Okay, question 6. The curve y equals a to the power x is shown in the diagram below. Given that the curve passes through the point 1, 3, write down the value of a. So we've been given a hint here, the value 1, 3, so we think of that as x and that y, because that's a coordinate, an x coordinate and a y coordinate. And we substitute these values in here. So 3 goes there and 1 up here. So we'll write that out again. We'll put 3 in as y from this, and 1 in as x. So what to the power 1 is 3? Well, a must be 3. 3 to the power 1 is 3. Question 7. The diagram below shows the graph of the function f of x equals 2 to the power x and its inverse function. Write down the formula for the inverse function. Well, the inverse of an exponential graph is a logarithmic graph of base 2 because this is 2 to the power x. So y equals log of x to the base 2. If it was 3 to the power x, then the inverse would be y equals log x to the base 3, and so on. Question 8. Last question, 2 marks available. Two functions f and g are defined by f of x equals x cubed, and g of x is equal to 2x minus 4. Find an expression for f of g of x. So the first thing we think about is what's in the brackets. So that's g of x. So really what we're doing is we're finding f of what this is, and it's 2x minus 4. So we're trying to work out f of 2x minus 4. So I'm putting 2x minus 4 into the f function, which is here. So that's what I'm doing. I'm cubing 2x minus 4 for a mark. You don't need to multiply it all out. You can just leave it with this for 1 mark. Last question is a similar idea. Functions h and k are defined in suitable domains by h of x equals 5x and k of x equals tan x. Find an expression for k of h of x. So I look to see what h of x is, and it's 5x here, so I'm putting a 5x in the brackets. So k of h of x is equal to k of 5x. So I'm putting 5x into the k function, so 5x here, which means 5x goes there. So really what that is tan of 5x. Mark. We need 6 out of 8 to pass. So you get a mark for sketching this, you get a mark for sketching that, a mark for writing this function, a mark for writing that function, a mark for working out this value here, a mark for writing the function for logarithms, a mark for doing a composite function question, and another mark for the final composite function question.